Hello folks, welcome to today's Expert Talks Online. I'm Lindsay Brewer, our delivery lead at Equal Experts. I'm going to be your host for today's session. Today's session concludes our four-part security series. And if you'd like to review any of the previous events in the series, then links to their recordings can be found on the Expert Talks Online section of the Equal Experts website. Today's event is going to cover some practical tips and heroic war stories and how to secure a large, modern, fast software delivery platform. We're really excited to have Chris Rutter, an alumni security consultant, join us this evening and be presenting. As we're waiting for more people to join, we'll have a chat about what's news in the security world. So is there anything people have seen that caught their eye in the world of security over the last week or two?
I think before everyone joined there, Lindsay, we were talking about, from a high level, the contact tracing apps. I think everyone weirdly had the almost exhausted, fed up of hearing the stories about it again. And it's not because it's not an interesting topic. I think it's because so many attempts have been made at creating this application. People have become almost numb to what's underlying. I know personally, I've got a couple of pen test friends who tore apart the last one that was, I think, was it the Isle of Man or was it the Isle of Wight? It was the Isle of something, whichever that original.
Isle of Wight.
It was the Isle of Wight, indeed. And they tore it apart, had some very high level feelings about it, but overall, depending on as an individual, how much you want to share, felt that it was fairly robust, and I believe the latest one sits in the Apple arena of how they do the contact tracing. And so, again, from a personal point of view, almost bored of hearing about it. Not that you should ever take it for granted, and as long as people do have their eye on it, that's really what we want to hear.
Yeah, security is a really important thing to keep in the forefront of your mind for anything you're working on or doing. Last week we had quite an interesting discussion on what happens when you post a photo of your boarding pass onto Instagram and how that can lead to all sorts of security problems. Right, okay, well, let's kick off for this evening. So I'd like to, again, thank Chris Rutter for joining us. He's an alumni security consultant, and he'll be talking to us this evening, which is the last in our four-part security series, covering some heroic war stories from securing a large, modern, fast software delivery platform. I had the pleasure of working with Chris for a couple of years at a large UK government public sector department, and highly rate him as a security engineer. So I'm really looking forward to hearing what he's got to say with no buzzwords, I understand, which will especially help me get my head around security. Following Chris's talk, we're going to be joined by the other people you can see who are going to be forming our starting point for a panel for a Fishbowl discussion. So if you've got questions during Chris's talk, if you can put them in through the Q&A widget in Zoom, and then vote for the questions that you'd like to see answered the most. The Fishbowl panel will then start covering those questions. If you'd like to also answer some of the questions and join the panel, please use the Zoom raise hand feature, and Steve Morgan, who's our facilitator lurking in the background, will bring you onto the panel. Great, okay, let's get started. So over to you, Chris.
Thanks, Lindsay. So welcome to my talk on platform security IRL. I must admit that in my mind, the stories were very heroic, and then when I put them in the slides, they were slightly less so. So I've removed that part from the talk. So hopefully you can tell me whether there's any hint of heroism or not at the end. Okay, so just a quick little bit about me. Lindsay's given me a great introduction there anyway. So my kind of pathway into security was, I started my career as a software engineer, and then began kind of leading security champion initiatives within engineering teams, and then progressed to kind of security architecture work, and then to sort of security tech lead engineer, DevSecOps, sort of transformation specialist is the only buzzword you're going to hear in the whole talk, I promise. I have had experience in the payments, banking and government sectors. I'm currently the lead security engineer at Clearbank, and I'll share the slides after the session. The talk aims are basically, hopefully, most of my talks I like to try to give kind of practical advice and based on like my own experiences to common problems, and hopefully the kind of the pragmatic and innovative ways that we've solved those things, given the fact that I'm lucky enough to be a dedicated security engineer and I'm given time and resources to solve these problems. This is a fishbowl discussion at the end, so I'd like to put out some general concepts for kind of how to implement modern security, and especially the approaches of things like standardization and convention. Because I've seen in lots of different environments, some people are vehemently against standardization and everyone should be free to do what they like. And some people are the opposite, where they're very opinionated and they feel that the way forward is that everyone should do things the same kind of to a point. So I'd like to kind of discuss some pros and cons of those approaches in terms of security. So the talk's about platform security. So first of all, you'd be surprised kind of the different definitions of what a platform is really online. This was from Wikipedia. I thought this kind of expressed it the most, in my opinion. It's an integration-oriented design approach that emphasizes systematic reuse for developing complex products based on platforms and compatible hardware and software virtual components intended to reduce development risks, costs, and time to market. So I think that's the key reason that most people tend to use platform-based architectures, in my experience, is to reduce kind of development risks in terms of how long development takes and failed projects and so on. And definitely it's to kind of reduce costs and time to market. And that's usually done by increasing efficiencies. I would also argue that in my experience, if done correctly, it allows you to massively reduce security risks, especially if you're intending to scale, especially if you're intending to rapidly ramp up the number of services or the number of engineers that you're going to be employing. I think the platform-based architecture, I've had some very good experiences, and I'm going to share some of those with you today. So if we just kind of get a diagram on the page, it sort of helps me see these things. So we had a long engagement with legal experts in a large government department. And when we say platform, this is kind of a sort of noddy, logical explanation of what that means. So you've got a lot of deployed microservices, which have kind of app code in each one. That's kind of unique business logic to each particular service, which has a unique kind of domain set of functionality with it. Then we have the first set of kind of cross-cutting concerns we have is libraries within the applications. So we have things like logging, things like web frameworks, even things like the container images, base images that these things are deployed into, can all be kind of part of the application, but are also cross-cutting and shared with other applications. And then we have the kind of core to the platform is the platform services. So things like telemetry, which everybody needs, platform applications who manage those shared libraries, build and deploy functionality to build your code and deploy it. And kind of in the modern world, security is a platform. I think we'll go into how that works a little bit later, but I think security is definitely kind of the last one of those boxes to become the norm. And for being in that box, the kind of security platform team, I generally feel like you come in late to the party and you have to try and do your best to sort of catch up. Obviously, infrastructure, it's what you might call a DevOps team. It's basically like a set of core infrastructure that everything sits on top of. So for the engagement that we're talking about, if we just give you a sense of the scale, so we're looking at maybe 60 engineering teams and sort of pizza sized. What is that defined as? Between five and six people getting your pizza. 1,700 total employees, around about 1,000 microservices, 6 platform teams. I missed one off there just because I wanted to look nice, but you get the idea. And generally 1 platform security team. In this engagement, we had 4 people. I wanted to just give you an idea of the scale of this engagement, but I think that's about the same as most engagements I've been on. I think when you're scaling out to a sort of platform environment, if you're in the security team, you're generally outnumbered, at least sort of 50 to 1 in terms of the engineers that you're helping build stuff securely to the number of security people within those engineering teams. So here's some lessons and techniques on working in this kind of environment and kind of building and operating that little security box within here. So if we first of all want to build that security box, like we said, a lot of teams might have started on the journey of building a platform, but they might not have included a security team as a specific part of that. So generally, when I found success with following the following format, so you generally need a kind of a lead for the team who really understands security architecture and security concerns, things like least privilege, and other kind of like important security requirements, and also who understands technology, who's basically got some experience working in an agile environment, or at least writing code or being close to technical security reviews. I found it really useful to have a product owner as well, because part of the kind of advice I'll give in this talk is that we should treat security like a product. We should treat it in terms of how much value is it giving us, how much is it helping people, rather than just some sort of compliance tick box, which it's sometimes seen like. And I feel like it's important to have that product owner to kind of look after that side of the vision of the team. Now, generally, we want these teams to be able to build things. We want them to be able to be hands-on and understand in depth the kind of things they're trying to secure. So I've had success with seconding different staff members. So you have app engineers, DevOps engineers, you have junior team members who can help. You have people from other platform teams who join from a while. I found this an effective model because it's rare that you'll get kind of funding or resources for a security team, to get 10 engineers, for example. And sometimes it's hard to find the role. There aren't many security engineers about. It's a difficult role to fill. So I found this is a good kind of, this is a good makeup of a team that I've had a lot of success with. So this was when we built this team, this was the kind of mandate. This is what we set out to achieve. So when we have this big software platform, one of the main things is that we want to build security into the platform. That's a key area. We have a good relationship with the platform. We're probably co-located, and we have an excellent capability to really give a lot of rigor to whatever they develop, these shared platform services. We want to focus on things like access management. We've got 1,700 people and 1,000 services on this platform. Access management is going to be a big part of our role. We want to improve our operational security capabilities. We want to really look, can we respond to incidents? Can we detect threats more effectively? Or how is our incident response like? Do we know what to do if we've got like a highly suspect alert on our network, for example? We also do help coordinate kind of vulnerabilities and incidents. I mean, that's a traditional InfoSec kind of role, but I think you'll always be able to add value as the kind of people who understand both worlds, the security side and the technical side. You'll then try and improve the app team development security. So this is the 60 pizza teams who are writing code. But as we'll see, kind of one person for 50 engineers, there's a limit to what you can achieve and what you should try and achieve. And we'll also kind of push platform-wide security initiatives. I think an example of that is things like encouraging people to use Git signing and pushing out that kind of initiative. The key things in our mind is that we want these things to be scalable and valuable. Right? That's all we should be thinking about as we do any security project. And the reason I think this talk's valuable is that, in my experience, they're not key requirements for InfoSec teams, and that it's not in the forefront of the mind that things are scalable, or even that you can prove value from the security activities. It's sometimes it's just, it has to be comprehensive. It has to tick a compliance box. So if we start with a couple of examples. So one of the first things that we did when we built this team was really improve our ability to detect vulnerable software dependencies. Now, it's always been one of my kind of top things on the list that I'll try and implement wherever I go, because I feel you get a lot of kind of bang for your buck in terms of reducing risk. So if we look at this diagram on the left, this to me is a standard sort of example of where your code comes from. You're building like a very simple web app that takes internet requests from the internet and sends it to a database. Now, the orange bit in the middle there, the business logic, that's the bit that you've written. That's the bit that does, you've written fully original code. It does something for your domain. Now, all the blue bits there are generally shared libraries. public libraries, open source a lot of the time, depending on whether you're using kind of Java or .NET. They're either open source or they're publicly usable libraries, which means that attackers are looking for them. You know, if it's open source, they'll be pouring through the source code. And even if it's something like Microsoft, you'll have pen testers, you'll have students looking to make a name for themselves, constantly looking to try and subvert these libraries, because they know if they find one vulnerability, they can potentially use it on hundreds of thousands of systems. The last time I did analysis on some code, it turned out that it was 97% shared code, 3% proprietary code. That's in terms of like lines of code bundled in your application. So basically there's a hell of a lot of code there that you've got in production that you don't own, that you haven't written, and that you aren't looking at and reviewing. And obviously for an attacker, there's tools like Metasploits, which mean that it's very easy to just download a tool that exploits an already cracked public framework, pointed at the framework, and there you go, you've exploited it. You know, things like the very famous TalkTalk hack were carried out with such a tool, you know, by somebody who you wouldn't class as an IT expert. I think it was a teenager who just downloaded the tool and clicked attack. So just explaining why this is one of the high value activities that you might carry out on a platform. First thing we do, we don't want to be like a traditional InfoSec team where we say, right, we need static analysis, we need dependency checking, we need to scan absolutely everything, and we need to build a proof on an order document that everything's been scanned every single day. There's no risk whatsoever on our platform. You know, we don't want to just go out and buy a tool first before we even understand how it works, how people would use it. First thing we do, I think, is we understand as a developer, what would it look like if I use one of these tools? So to me, the standard flow for this is I check out an application, whether it's a binary or some source code. I do a scan, I alert on the findings, then someone has to investigate any findings. You know, if you scan a particular app, you're probably going to get maybe 10, 15 findings the first time you scan it. Then some of the findings will be false positives, which you can suppress. Some of them might be real. Some of them might be require an immediate upgrade because they're really risky. Some of them might be less so risky, slightly bad practice. Let's upgrade it in a month or so. And then eventually we need some way to enforce that these things are happening. You know, even if we are kind of laissez-faire and we allow people to handle their own security, we need some evidence that these things are being fixed. But the traditional approach from an InfoSec team, in my experience, is let's buy the tool, let's give it to all of our 50 or 60 teams, let's put a security champion in there, and let's say, good luck. Right, now you're handling vulnerable dependencies. Now what actually happens, one of the buzzwords that I mentioned in the title of the talk, so we're shifting left there. You know, if we put this scanning in every single development pipeline we have, and we ask every single engineer to start owning these things, we've shifted left. You know, that's what the industry's saying we should do. And we give ownership to engineers. Again, people make good noises about that kind of stuff. But when we look into the practicalities of this, you know, we've got 60 teams. We've probably got, you know, 500-600 engineers. The investigation of each of these findings takes between 30 and 60 minutes, in my experience, to do a full investigation of what the actual problem is. You've got to dig through lots of CVEs. You've got to try and find an article on Red Hat that explains it. You've got to try and find a pen tester who's been kind enough to explain how this works, read through source code, really understand what the issues are, how serious they are. You've also got to buy 50 licenses for a tool. And these vendors, that's their business model. You know, you're going to spend a lot of money on 50 users. And these tools generally require a lot of investment to set up. You know, you have to build a server a lot of the time. You have to manage the users on there. It's turning into quite a large project, this. Also, the security team is now going to be consulting with 50 different teams. So you've got 50 different people doing investigations. That means your team of security engineers who have obviously got other improvements projects to work on, have now got to consult with 50 teams investigating 50 sets of results. It's also, if you're not kind of dealing with all 50 teams, it's very difficult to ensure that these things are being done in a robust manner. You know, there could be a very serious vulnerability and someone's just in a rush and you can't really guarantee they've done, you know, they've spent the 8 hours or so it might take the first time they run this scan. But that's some problems that I feel with the traditional kind of let's shift left, let's put it in every pipeline, give the engineers the ability to deal with it. So we did a POC of this, and if I'm honest, we tried the traditional approach. You know, we did a POC of a scanning tool, we followed the standard approach, we did a POC with a number of users. We said, okay, right, let's get 10 teams and let's scan all of your code. And when we scanned all of these apps, we realized, hold on, not only are the apps using the same shared code most of the time, and 90% of the time they're all using exactly the same libraries. Those libraries are actually owned by one of our platform teams and managed by one of our platform teams. You know, we give these software dependencies as a package that teams can just kind of drag and drop and be using the same functionality as everybody else. So we think, okay, so now we know that if we put this out to 50 different teams, basically we're going to have 50 engineers doing the same investigations on almost exactly the same findings. Now, when we talk about value, and we talk about pragmatism, that's starting to smell a bit fishy. You know, that doesn't sound like we're making effective use of our resources there. So what we did is we decided to be a little bit pragmatic. So we said, okay, these shared libraries that are managed by a platform team, and what we'll do is we'll just scan those libraries. There's about 10 of them, but they're used by all of the other 1,000 services. Let's just scan those on a nightly basis. You know, let's scan them once and see what we find the first time. And then let's scan those on a nightly basis so we find any new findings. As platform security team, whatever comes up, we'll dedicate the time to do a really thorough investigation of those findings. As soon as we triage those things and we figure out which ones are false positives, which ones could be issues, which ones are definitely really scary, we then work with our platform team who maintains those libraries, who builds an updated sort of shared library, tests it on most of the normal scenarios, and publishes a new version ready for teams to use. Now, this is a very easy upgrade path for a team now. So in the last kind of iteration, we said, right, you've got to investigate everything. You've got to decide which versions you need to upgrade to. You've got to decide whether you're vulnerable or not. Right now, we've centralized all of that. You know, 50 people were going to do the same thing 50 different ways. We've centralized it. Security experts have done the analysis. The platform experts have tested the code. The upgrade path now is pretty much just, you know, just uptick a version number and you're golden. It's already been tested. It's already been reviewed by security. We can also, a lot of these findings aren't quite black and white. It's not like you're vulnerable if you use it or you're not if you don't. A lot of the time you can have a code library within your package and you have to be using it in a certain way to be vulnerable. So as well as just giving out like an order to upgrade, the platform security team can do a really thorough investigation and publish the results of the investigation. You know, this is what the vulnerability is. Am I vulnerable? Yes, if you use these annotations. No, if you're not. How can I remediate? You know, if it turns out that it's a really serious vulnerability and I need to do something tomorrow. You won't find this kind of simple published information specific to your domain anywhere on the internet. You're going to waste a lot of time with a lot of people trying to figure this stuff out. If you really want to be clever, you can then, you know, write a static analyzer, which then scans for these particular parts of your code. And again, because you don't expect these things to be happening very often, you can do that in a centralized manner. You don't need to put these in everybody's dev pipelines. So then when we talk about enforcement, sorry for this very naughty diagram, but if you look at your build, test and release pipelines, so we work on a platform with a build and deploy team. Every single release pipeline follows the same pattern. Every single release pipeline goes through the same release steps. It has the same test cycle, although teams can modify what happens inside of that cycle, and it goes through the same build cycle. So it's very easy for us now to add a tool which allows us to configure a policy where we say, okay, based on that last security upgrade, you have to upgrade to the latest shared library, and based on how sensitive we think those things are, you have to upgrade within 2 weeks, or you have to upgrade within 2 months if it's just considered bad practice. And by the way, if you're doing any of these things, you have to upgrade tomorrow. So that's the approach that we took out. And the benefits of taking out this approach that we felt that I've kind of been through is that we had in-depth analysis on all of these findings. You know, we're pretty sure we got maybe like 95% of all of the shared libraries in the platform were homogeneous. We're confident that all of those, you know, high risk, the things that are exposed to the internet have all been reviewed by a security engineer with an incentive to do a good job. The upgrade path is very easy. Upgrade to this version of the shared library. Very simple, very easy to enforce. The implementation effort for this took us, I think it took us about 6 weeks, maybe to get a first iteration of this, maybe 2 months. There was the ongoing load of the security engineering team was very low because it scaled out. We knew the only thing that would give us a lot more work would be if suddenly a lot more vulnerabilities came out. You know, it wouldn't hurt our ability to scale if we suddenly doubled in the number of microservices or teams, because as long as they use the same shared libraries, we get double the scale for free. It meant that we didn't have to pay through the nose for a scanning tool or go through the kind of, you know, sometimes even budget meetings and trying to get such a tool signed off. And we really felt like we made a decision where we said, right, if we can get most of this value in 2 months, even if we know that there might be a slight chance that somebody might use a new library, a Snowflake library in one of their apps, and we haven't scanned it. I think we took that trade-off where I've seen projects like this in enterprises take 2 years to get a comprehensive vulnerability scanning program set up. I think we got 80%, if not more, of that value for probably way less than 20% of the time it took or the resources. So I think you can apply these concepts with any scanning tool. Dependency checking is the example I used because it's the first one that we looked at. But basically, you know, like shift left is a great idea, but only shift left if it's valuable and only shift left if you can manage it. Don't just blindly put static analysis in everyone's pipelines and say that, you know, you've shifted as far left as possible if you don't have the capability to understand what someone does when they get one of those findings, or, you know, how often they're going to come and ask you for help, or whether or not the findings are actually valuable or not. It's your responsibility to understand those things. Ensure shared functionality is centralized. If you've got shared functionality for anything like web frameworks, cryptography, logging, any of those cost-cutting concerns, why would you duplicate that code many times? It's not even a security kind of concept that, you know, it's better to centralize those things, in my opinion. And then it's a lot easier to scan it, whether it's statically scanned or dynamically scanned. We can scan it once, experts can look at it, everybody just has to know that they're using an approved library. I think we should focus on value over comprehensiveness. How much risk am I going to reduce for the effort I'm going to spend on this security improvement project? It's easy to say that, but sometimes you have to fight this fight with auditors. You know, auditors and InfoSec teams will just love the idea of something being comprehensive. I want to prove that I've got fully comprehensive scanning on every single app that I have, because that looks good to an auditor. It's a lot easier to prove that than it is to prove, well, is it actually valuable? Are we actually getting anything from this fully comprehensive scan? So I think it's your job as a delivery-focused team to fight that fight. And having a product owner and having engineering experience in the team really helps with that. And I think we should always try and, you know, deliver slices. You know, we should chop our project up into into sort of like valuable chunks, like any other project should do. We shouldn't just spend 2 years, you know, doing the same thing just to say that we're comprehensive. Okay, so that was one example of a success that I felt we had. The next example is, this is a big one. So we wanted to improve how we handled database access management. So remember, we've got 1,000 microservices here. We've got a few different zones, like trust zones. You know, some of them are the public internet. Some of them are more trusted and deal with things like payments. Some of them might be like a super internal, super trusted endpoints that deal with, deal with sensitive government integrations. Now, what we really want to do is we want to have every single application in this whole stack have its own unique kind of database user and its own unique database permissions. Because what happens if one of the applications gets compromised and it's got keys to everything? you know, the scope of that incident is a lot worse. What happens if some malicious code gets its way into one of the applications, or it gets done by one of the vulnerable dependencies, and it's got keys to the whole database and every table in it? Again, that's not a place we want to be. However, how do we manage 1,000 different database users and access profiles? How do we do that in a scalable manner? So these are the kind of things that we need to do in any solution to that problem. You know, you need to be able to create a new application. That new application needs to be able to have a set of permissions attached to it. Which DB should it speak to? Which tables can it access? Can it read? Can it write? We need users created in the DBs to reflect that, have some kind of credentials system, and they need to be stored and accessible by the application. We also need to be able to change this if something like the application is torn down, or for some reason it needs access to a different database or anything like that. Our traditional approach for this, you know, a few years ago everyone did it this way, and some companies still do, is you'd have a DBA team. I'm not saying nobody has DBA teams, but generally in my experience, people are moving towards like a kind of you build it, you owned it sort of mentality. And a lot of modern sort of DevOps environments are phasing out like a dedicated team of DBAs. The flow would look like, I'm an engineer, I create an app, I fire off a ticket to a DBA, I tell them I've created a new app. They then have a word of security, they wait a couple of days, they make sure that they get someone, emails them a sign off. DBA logs onto the database, manually creates a user or manually runs a script, and then manually stores credentials in the secrets manager. So lots of manual stuff here. It's slow and tedious, it's prone to error, and it actually encourages less granular security, because people tend to just design the systems so that they don't have to go through this rigmarole. And you lose any, you lose kind of architectural granularity. Yeah, I mean, basically what I've just said there. One positive benefit of this approach is that it is comprehensive. You know, everything is actually reviewed, all the permissions, and at least we do have defined ownership of these databases. You know, somebody does own them, and they are responsible for them. But it doesn't scale, and you know, it takes too long for our requirements. There's also a traditional approach too, which is basically you just kind of put your head in the sand and you don't deal with the issue, and everybody gets admin. So you create one set of users and everybody gets them, and it can access every database, because that's the easiest way to go forwards. Fair enough. Maybe you're in a startup, you know, maybe you're in like rapid development mode, but if you're not careful, this gets forgotten about, and then 2 years later, suddenly you're in the situation where it's quite difficult to fix. So how do we make inroads at fixing this? So on this deployment that we had, so this was already there when I joined, a fantastic system where we really standardized application creation. So if I want a new microservice to be created, I don't go in and do much myself. I don't create stuff in GitHub. I have a Jenkins job or some kind of repeatable mechanism where I literally just type in the name of my app, whereabouts I want it to be deployed, how many instances, does it need a database, and okay, what type of app is it? In this case, we've said front end. Create. Once I click that button, what then kicks in is a fully automated, repeatable process where my app gets created for me with a name. The database user gets created with the same name. What we can now do is we can implement an architectural pattern where we say, right, you are not allowed to have access to any other database than just the one that is called the same as you are. So we've got an app called Customer Account API. We're saying that, right, you're not allowed to access anyone else's data. You've got your own database. We're going to call it Customer Account API. That's the only one you can access. Anything else, you've got to use an API. You've got to use another service. And that's a pattern that a lot of people aspire to. Very difficult to actually, you know, enforce until we use this approach, where we funnel every single new application through this process. We also use this process. We've created the DB user. We also use this to get the credentials out and store the secrets somewhere that your application can get them when it's deployed. We can also go further and define any kind of cloud permissions your application might need. Say you're using like IAM credentials or dynamic credentials. Everything's done in this one way using a convention-based approach, and everyone basically gets security for free. What we also get is a standardized deployment mechanism. So it automatically generates this deployment descriptor, which you need to be able to deploy your app. Automatically gives you a database connection string. And you know that you could go to production now, basically. You could put hello world in this app and it's ready to go to prod. That's an attractive thing for any organization to go to prod so quickly, but it's fantastic for security because it's pre-approved. You're guaranteed that that there's no kind of widely permissive rules being created or anything like that, and you don't have to review nobody has to review every single app that's created anymore. Much more scalable. In an ideal world, that would be it. We build this thing from the get-go. It's not an ideal world. You've always got to deal with legacy. If you were to put something like this in, there's going to be services in the past that didn't follow these patterns that you have to cater for. There might even be snowflakes in the future that legitimately need access to more than one database. So then we build in a mechanism where you can declare those things in code. Again, automatically created, not by a pipeline. The way we did it is this was triggered just by a code commit to this repository. And this overrides that kind of one database per app and allows an app to speak to multiple databases. As soon as you commit something to this repository, it automatically applies it through the mechanisms we implemented, and then that service instantly has access to those databases. Now you can implement a much more slick approval process in this using PRs and GitHub, and it means you avoid tickets, you avoid all that kind of stuff, and you can very easily you don't make it too easy, but you can basically get the right eyes on these type of things to ensure that it's done for a legitimate reason. What are the benefits? So yeah, everything's accessed by namespace. It's all a convention-based approach. Everything is fast and automatically provisioned. We can go to prod instantly. Security controls are built in and free and pre-approved. There's no need to do a threat model on how you've done your secrets management or how you've done your database connections, because we know it's approved. This approach could be used not just for database credentials. It could be used for anything where you need to standardize access to things. You can link in deployment pipeline creation to that job. You can link in how you create your Docker images. If you're using cloud-based services, you can link your IAM policies. It can all be done at the point of creation. So the concepts we're looking for is that we want to automate app creation because it's the easiest point to, at the beginning of an app's life. Let's make sure it's secure from the get-go. Standardize architectural patterns. There's a trade-off there. A lot of engineers want to be able to build whatever they want to build using whatever technology they want to build. I understand that, for being an engineer, but you have to balance that with, would you pay the cost of everything taking 3 months longer to be able to do that if you could develop stuff much, much faster and more securely and easier if you just followed the same patterns as everybody else? The concept of this is that all this stuff is built and owned by a platform team. So it should be managed and built to a high level of quality by a team that's just incentivized to maintain that quality. And they're never going to be pulled aside with business requirements and deadlines, for features that get in the way. And always kind of codify for legitimate use cases. You can't go in with like an ivory tower approach and say, what you did 2 years ago is terrible and you have to change it instantly. You generally have to cater for gradual migration of those things. So the last sort of innovation that we did, or the last kind of process that I think we did really well on this engagement. So it's all well and good. We implemented the automatic database provisioning system. The way we actually worked to implement that system, the solution I feel was very good and it worked really well. It took us a long time to implement, and the way that we worked, it actually took more months than we hoped. A lot of the time was because we were managing kind of big bang migrations, and a lot of time we had kind of drift in between teams when one team would finish a bit of work and then another team would wait until the next sprint to pick it up and all that kind of thing. So that it almost made it prohibitive to do these kind of really big, important improvement projects going forwards. Now, obviously, anything that stops you doing the right things, we should swarm on, and we should make it better. It's kind of one of the core tenets of DevOps. So this is what the project looked like a little bit. You know, each platform team did their own bit, and then there was quite a lot of work, kind of worrying about a big rollout, a big bang. Like, are we going to impact functionality? So what we did is, I won't take credit for this idea, but it worked so well, is that we used the concept called the Tiger Team. So what the guys did is they put together a team, a virtual team, which was built from a rotating set of engineers from each of the platform teams. So I was the security engineer for a while. We had people from the build and deploy functions, infrastructure, people who dealt with applications. And you have an architect who's there for continuity. You make sure the design stays, follows the same lines. Now, the goal of this kind of project is not just to have teams, not just to cut down a project drift, which it does, but also to deliver fast chunks of value. What we want to avoid is a project that takes a year, migrating to a new platform without any value. What we want to do is we want to give small chunks of value every 2 months, every 2 weeks if we can. Test our assumptions in production. And ideally, we want to do this with security sign-off. We want to do this all the way. We want to build this stuff in from the beginning. Now, a standard approach to this kind of project, an InfoSec team isn't going to like it. You're telling them, well, hold on, I've got an 8-month-long project, which is going to deal with some very serious stuff that affects a lot of people. And I want to go to prod after a month. It's not going to be finished yet, but I want to go to prod anyway. Now, that's a difficult conversation to have sometimes with a security team. You say, well, it's not finished, it's not secure. It hasn't been pen tested. We can't afford a pen test every 2 months. We have to do the pen test at the end. We need to do the architectural review at the end. This kind of kills the idea, to be honest. You can't release to prod early. You're not really building security in the beginning. You're not going to get any of the benefits that you wanted from this Tiger Team approach. So what we did is we developed an approach called kind of just-in-time threat modeling. So what we did was at the beginning of the project, we did a threat model of anything that was new. In this case, there was like a completely new deployment mechanism for all services, and a completely new architecture, network architecture for all services. We threat modeled the two things, and we pulled together a list and said, right, by the time it's done, these are all the things you need. However, let's have a look and let's see what these iterations look like. Let's see if you can make me confident that based on what you're actually going to do in this iteration, I don't have to worry about a lot of those things. We're going to worry about them later. We'll do them just in time. So the example project that we worked on was basically changing how the whole platform deployed applications in terms of changing its kind of container orchestration solution. Pretty much the biggest thing you could possibly change. It affected every single app on a lot of systems. So this is what the iterations look like. So we got together and we agreed, okay, iteration 1, I just want to create a dummy service that does nothing in a private zone, which has got no internet connection and no database access. Now, lots of the stuff we identified in the threat model isn't really required at this point for it to be secure. None of the database security controls are required here. None of the internet-facing security controls are needed. All you need to prove to me for this iteration to go to prod is that nobody can get to this dummy app, and that it's not deployed in the same place as existing prod stuff. That sounds easy, that's reasonable. That's probably like a user story's worth of work. We did this successfully. They went to prod. We're happy with the security. Iteration 2, same thing. Okay, so now I do want internet access, but I'm going to lock it down to the office. So only 10 of us can access it. Okay, that's cool. Now we need to make sure that that whitelist is really secure and really effectively put in place. But we don't need to do things like rate limiting on the endpoint because, fair enough, you're not going to DOS yourself, and we understand that's fine. Iteration 2 goes to production. Brilliant. Okay, iteration 3. Now we need database access, but it's just a database that holds kind of public data. It's not sensitive at all. But we need to test the database connections and test, the mechanism to get the credentials in there. Okay, cool. You've got to protect those credentials, but just make sure you've got, no access to any of the database. You don't need to worry about the full security controls that we'd ask you to put in.
It's just to give you a heads up, we'll need to move on to Q&A in a couple of minutes.
Yeah, so this is the conclusion now. Perfect. I thought this was going to take half an hour, and it always takes longer. Benefits of this approach, obviously, you get much faster delivery. So I think we took a project that might have taken a year, and we started getting value. I think within 2 months, we got a slice of value. We got services in production. And then every month or so, we were deploying a different set of valuable benefits. The security team were involved in the entire project. So whoever was the engineer knew exactly how this thing worked from the beginning. Any review at the end of the project was going to be very easy based on their own threat models. We're able to design the things to be security from the get-go. Like every month we're designing security capabilities in with the design teams. Security is considered an enabler. So we're seen as partners, technical partners, providing technical advice. We're not seen as a box checker or a compliance jockey who just comes in at the end and wants to do some paperwork. And it's a lot cheaper to build stuff in early than it is late in the security review. So the final slide, basically conclusions. I guess some of these might be talking points because they can be contentious. Standardization and convention is the easiest and cheapest way to scale security. So from my experiences, I firmly believe that. It is at the cost of engineer kind of creativity and freedom to experiment with new technologies sometimes. But there can be a balance achieved, which is the next point. Understand what your teams really share and really do the same, and what do they truly need to customize. Sometimes that can all be within a Docker image they deploy is all they need to customize. Sometimes they really do need new architectures and new platform tools. Many times people don't. You need concrete ownership of platform capabilities. You can't just have one person who's an engineer who owns the telemetry of a platform, because they're never going to have the incentive or the ability to do a good enough job on it. Don't be scared to take the 80%. Don't feel like you have to always be 100% just because it's security. Take the valuable kind of gains you can get. Use cross-functional virtual teams to build faster and more securely, and always make sure you include security in those teams. And use just-in-time threat modeling to support those rapid delivery projects. So I think that's it. That's the end of the talk. Over to you, Lindsay. Thanks for listening, everyone.
Thanks, Chris. That was fascinating. If you can stop sharing your screen now, Chris, that'd be great. Thanks for the questions that have been put in through the Q&A widget. If you want to vote up questions that you'd most like to see answered, we've got about 12 minutes to do the Fishbowl panel discussion. The panel we've got is quite a wide-ranging group of people from the network. I think all of us are currently at various public sector departments in the UK government, doing a variety of delivery lead and security roles. So I'll let people introduce themselves when they pick up their first question. So let's start off with a question from Tom Gibbs, which is, outside of scan results, how do you go about communicating new CVEs, mitigations, and best security engineering practices to various teams in ways that are relevant to each team and minimizing duplication of efforts? So who would like to pick this up first?
Yeah, I mean, I can give an answer, but if anyone else has, if you want to hear somebody else's voice for a while, then go ahead.
When you kick off, Chris.
Yeah, so I mean, there's a few different techniques that we employed. So if we look at the best security engineering practices, a couple of different techniques we used were, so we did kind of tech talks, which were recorded, where we could, record like a presentation similar to this, but a bit more specific to like a particular design pattern. A little bit more labor intensive for those ones, but I feel like they really kind of explain concepts well. We also made use of blogs. So I know, Lindsay, you helped me publish a few blogs where we put things like the explanation of a CVE, of a vulnerable dependency, and we'd make it really practical, and we'd say that, don't bother spending 2 hours on the internet if you don't want to. This is how you're vulnerable, and this is how you fix it. And then the other way we did it was by making a lot of use of Slack, which is one of the best tools I've ever used for security, to be honest. I think if Slack's used effectively and you manage your channels really well, and you've got a kind of a channel for interesting security things, and you've got a channel for important, look at this now, security things, then I found that a really good mechanism to share information.
Great, thanks, Christian.
It strikes a chord. It's interesting. For me, if you're talking about CVEs to people, unless they're security people or they've got a vested interest, or maybe a developer who's got a particular passion for security, something's gone very wrong. Most people are disinterested. It goes over their head. They'd just rather not talk about it. They've got the day job to do. And you should always try to be in a position where you don't need to explain these things to everyone. And it's tied to there's someone threw in a question around how to solve the patching problem, which after 10 years of working in the industry, I don't believe there is an answer to solving the patching problem. In every reasonably large organization, it's just a nightmare. So you have to solve the problem through emergent properties. So by having immutable builds where you can test up properly, you've got blue-green deployments where it's fresh all of the time. So the CV problem goes away, the patching problem goes away, and it isn't just a job for someone to do to systematically go through and try and upgrade things in situ. Although saying all that, and it's really great, it's just unfortunate. I don't think most organizations are yet at that maturity level where they can do that. Yet the last couple of years I've seen lots of headway moving in that direction. And I think hopefully, unless you've got, like I say, that interest, you'll never have to mention CVE again.
Yeah, I fully agree with that point.
Thanks, Tony. Anyone else want to add to that? I think just something from my own experience with working with Chris, where we had a number of CVs that a large number of teams needs to respond to. I completely agree, Tommy. Trying to explain the CV was a kind of quite a big waste of time, but instead trying to communicate the business impact to the teams on what could happen if that exploit was executed. That was much more meaningful to the teams, but also to effectively their product owners who are trying to decide how to prioritize these CVs. Okay, you're right. Should we go on to the next question, which is from James. Again, thanks, Chris, for a great talk. So what open source container scanning tool have you used that works well for a shared libraries approach? And are there any framework examples that you could recommend for starting off supporting security testing within a CI/CD pipeline?
Let's have a look. Okay, so we actually did a proof of concept using Aquasec, which did seem to get some quite good results for us. Although we did find it slightly difficult to get up and running. I think they might have improved that now. So I think that's kind of one of the market leaders, and they do a free scanning tool. We didn't roll that out as a full kind of scanning capability. So I can't give you kind of as much as many heroic war stories on that one. But we found the tool pretty useful.
So was that Trivy, Chris?
Sorry?
Was that Trivy, the Aquasec Trivy? Trivy's the open source version of their online version.
I'm not sure if it was called that then. They might have rebranded it. But
okay, so I can also recommend that. It's one of them, once you get past the brochureware and the glossy site that says it can do everything, if you take it with a pinch of salt and you're willing to put some effort in, and it's low-level stuff that people really have to get into the weeds with. If you can achieve it, the results... well, to be honest, I don't think there's that many out there, particularly for container stuff. So I would put the effort in. It's probably worth it.
I've just tried to understand exactly where the right place to scan is. Where are you going to find the most valuable findings, and where is it going to be the most manageable and the least overhead? So maybe the container is the place for that. Maybe maybe when you build your application binaries might be a better place in some cases. But yeah, I would just really consider those points when you decide. And any framework examples to support testing within a CI/CD pipeline? If I'm honest, I've always found kind of like a polyglot approach the best, sort of picking and choosing different tools depending on the environment that I'm working in. One of the best tools I think for dependency checking is called SNCC, Nick's a really good tool. It's very lightweight. I think the pricing models are quite sort of like quite modern, and it seems like it's engineer focused. Although I think it's mainly cloud based, so sometimes that's an issue for getting sign off. So with stack analysis, sometimes I'm tempted just to stop building my own kind of basic rule set in something like find sec bugs. I think you can get a lot of value out of those things. Get like a basic SQL injection XSS pack. You'd be surprised how they kind of compare to the really expensive proprietary tools. So what I'd say to you is the hardest bit usually isn't getting a good scanning engine. The hardest bit is building it into your workflows and understanding what you want to scan and exactly what you want to get out of it. So I'd just start with a cheap tool that gives you some sense of value, some findings, build that into your pipelines, whatever it is. That's the hard bit. Get your engineers using it, that's the hard bit. Get them fixing things, that's the hardest bit. And then you can look at upgrading to something that scans more effectively.
Great, thanks, Chris. All right, let's move on to a different type of question. So Tom, I'm just going to skip yours for now. What's the panel's experience of helping to integrate security into agile ways of working? So what things have helped you, particularly people that lead teams, help their teams take security seriously?
I'm quite happy to sort of give some input on that. So my name's Lucille. I'm a delivery lead at a large government organisation as well. And I worked with Chris. In fact, I was a delivery lead for the Tiger team that he mentioned. I found it really, really useful to have security embedded in the team from the start. They were always there to provide us with support. They would come to our refinement sessions, so they knew what was coming up, and we had regular demos where they would take part as well. So, but it was knowing that the engineers could draw on their experience and their expertise when they needed to. So I've worked in many an organization where security is just an entity or even an enemy for most deliveries. So it was refreshing to have a different way of working where security was there from the start, and we could make sure that we were building the right thing. And also, you know, in a larger government organization as well, obviously there is a lot of governance that may be outside of our control. And the platform security team were excellent at really sort of being that bridge between that sort of external governance and what we were doing internally, and helping us understand and make sure that we could give them confidence that we were delivering the right thing. So I think it definitely is a way of working that we'd want to promote for every sort of large scale project, and even smaller ones that we know that PlatSec is there to support us.
Yeah, just to add to that, thanks Lucille. And some of the kind of attitudes that we had that allowed that to happen were, when we came in and did a security review, we didn't want to kind of like rip you to shreds. We didn't want to prove how clever we were. We didn't want to prove to say, look, I can poke a million holes in your application. You know, because that's not going to help anybody. It's not about poking all the holes we can see in it. It's about understanding what the important security factors are. Where can we make a positive impact? And then let's work with you to try and make that happen. And I think that's if security teams have that kind of attitude and make sure that every single review they do has valuable output and engineers can see the technical value in it, and you're talking sense, then I feel like engineers just start wanting to work with you. They'll reach out of the blue and say, I want you to review my project because I feel what you do is valuable. But I found that's by far the best way to get engagement, is just make sure you give them value, and then they'll come back for more, basically.
Thanks, Chris. JP, did you want to add something there?
Yeah, so I'm JP. I'm a product and delivery type person, I guess, who's working with a large government organization. I think the main thing that we found is actually the execution of that activity. So when people say working with, it's what that actually involves and how that's facilitated. So a lot of the time, people, as already mentioned, don't want to be involved in tick box exercises or just going through gates. And we found that the best way to do that is just to emulate other engineer practices of collaboratively working together through pairing. So, for example, I work on the platform team, and our engineers pair with people of any discipline that's needed to, you know, execute or complete certain activities or meet certain requirements. And in the case of security, we've certainly had instances where engineers are working with security experts in order to do that sort of thing. So I think when we talk about ways of working, it's actual behavior that already exists, people are already familiar with, and that's what working with them as like an extended team as and when necessary, for me, has been really beneficial.
Great. Okay, thanks for that, JP. Well, I'll just do one last question from Tom Gibbs. So his question was about, if you're having a shared set of libraries, did you intentionally discourage teams from using a more diverse set of technologies? And how much control did individual teams have over their stacks?
So I must admit, Lindsay, you might be able to answer this one better. So that convention was already there when I joined. I just realized the massive kind of benefit to security that it could give.
Yeah, the platform that Chris is talking about in this large UK government organisation was what we described as being an opinionated platform. That meant it allowed teams to join the platform and deliver really, really quickly. So have a team join and get things to production that could scale to coronavirus service levels within weeks. We achieved that by limiting the tech that teams could use. So they could only use a certain programming language, certain data storage mechanism. And we took away all of the need to set up CI/CD or monitoring or alerting tools. All of that was provided for free. Teams then just could focus on how to structure their service in terms of breaking into microservices, focus on the business logic of those services and the user journey. And that worked really well for us. It doesn't work in all situations, but it certainly scaled and given us a lot of speed. Anyone else want to add to that? Go Dennis. Dennis, you're on mute.
Hello. I was just gonna, I mean, I guess one of the nice things about the environment that you were in, Chris, is that it was sort of ready for your approach in a way. But I just wondered if you thought about like how you might deal with an immature client, immature in the DevOps sense. Like I'm thinking of like, say, like a local council or, a smaller organization that doesn't, tend to have, the traditional kind of paper administration approach to security. And it's quite a conversation, not only to convince them of an approach like you're talking about, but also just that DevOps is a pattern that they should be following, because often they're not actually building their own applications, they're buying them.
Yeah, I think that's I've definitely seen that in places that I've worked. I think it's a wider question than security. I mean, in terms of security and kind of encouraging people to use like infrastructure as code and encouraging them to standardize, I generally try to pick a painful part of their existing architecture, something that's not very resilient or something that has a lot of release failures, and I try to piggyback a kind of security benefit onto a solution to that problem. So they're kind of getting two birds with one stone. It's just, it's kind of like they thought they were hiring somebody just to do security stuff, and then you come in and you kind of help them with a different problem they've had while also improving security. Is one technique that I've used. If you've got the expertise to do it. If they don't even have the requirement, the ambition to improve the architecture in general, I think that's really hard. From an engineer's perspective, that's quite hard. If there's no ambition to improve scalability or improve performance or improve delivery speed, it's quite hard with security because we haven't been hacked yet. So you can always go on the kind of like fear, uncertainty and doubt path, which something like a tabletop exercise where you kind of simulate an incident that's happened, and you ask all of the senior guys, a chain of senior people to be in the room and say, what would you do in this situation? And then you ask the technical staff, like, what would you do? Would you have enough information? Would you get the right logs? Would you be able to report to the ICO knowing what's going on? A lot of the time, the answers to those questions will be a lot more difficult because they're not using a DevOps-based approach, or they're not standardized, or they've got really legacy old technology. So that's one way that can improve the ambition, I suppose, of an organisation. But it's kind of like a nuclear option, I suppose.
Great. Okay, thanks for that discussion. We're going to have to wrap up there because we're just past 7 p.m. Many thanks, Chris, for your talk. It was really interesting. And many thanks to Lucille, Tommy, Chris, JP, and Dennis on the panel, and for the people from the audience that have posed their questions. Next week is going to see the start in a new series of expert talks online that's going to spotlight various client engagements that we've been involved in. It's going to start with the Australian neobank, Zinger, and it's going to be a breakfast slot. So if you're up at 7:30 a.m. In the UK time zone, that is, then please come and join us and listen to our speaker, Rohan Sharp, who's going to be talking to us from Australia. Rohan's the co-founder of Zinger, which he had been working with since their conception a few years ago. Zinger uses events very heavily in their platform, and the talk's going to go through how events are used, why they're really important to the architecture, and the lessons that they've learned in the development of this system. And you can sign up for this talk at equalexperts.com. Thank you again for everyone that's participated in today's session, and hope you have a good rest of your day. Thanks, folks. Cheers. Bye.
Bye, guys.
Bye.